Hello everyone, welcome back to Physics HQ. This is Professor Sandeep, your tutor for the class 12th lecture series. Continuing with the lecture series of solving MCQs and sums of class 12th physics, today we'll be covering the part 3 of textbook unsolved sums of chapter 15, structure of atoms and nuclei. We have already covered the MCQs and two parts of sum solving. If you have not checked it yet, please check it out by clicking on the top right eye icon. Let us start with the first sum for today. The isotope of cobalt with mass 57 decays by electron capture to iron with a half-life of 272 days. The ferrous nucleus is produced in an excited state and it almost instantaneously emits gamma rays. Find the mean lifetime and decay constant for cobalt. So we got half-life given over here, which is 272 days. We can convert this into seconds by multiplying it with 24 hours, 60 minutes and 60 seconds, and this will give us 2.35 into 10 raised to 7 seconds. Next, they have given that activity of radiation source is 2 microcurie. So initially we got activity as 2 microcurie, which is 2 into micro is 10 raised to minus 6 into curie is 3.7 into 10 raised to 10, which gives us activity at t equal to 0, which is 7.4 into 10 raised to 4 disintegrations per second. We know that half lifetime is given as 0.693 divided by lambda, and this lambda is nothing but decay constant, and the inverse of this lambda or decay constant is nothing but the mean lifetime. So we can rewrite this formula as t half is equal to 0.693 into tau, which is lifetime. So we can find out the mean lifetime. This is equal to t half upon 0.693. This is equal to 2.35 into 10 raised to 7 divided by 0.693. This will give us the mean lifetime as 3.391 into 10 raised to 7 seconds. Now we can find out the decay constant lambda, which is inverse of this mean lifetime. This will come out to be 2.949 into 10 raised to minus 8 per second. Next, they have asked how many nuclei does the source contain. So initially the activity is given as n0 into lambda. We already got the lambda. We need to find out what is n0. So n0 is a0 by lambda. a0 is the initial activity, which is 2 microcurie. जो हमने convert किया हमें मिला था 7.4 into 10 raised to 4 divided by lambda we got as 2.949 into 10 raised to minus 8. This comes out to be 2.51 into 10 raised to 12 nuclei. In the third part, they are asking what will be the activity after 1 year. Now we all know that the time over here they are asking is 1 year. So 1 year can be converted into seconds. ये हमने पहले भी किया हुआ. It comes out to be 3.1536 into 10 raised to 7 seconds. So we will use this formula. Activity at time t, which is given as 1 year over here, this is equal to activity at t equal to 0 e raised to minus lambda t. So activity initially was 2 microcurie, so we will keep it in this form only, so that final answer भी हमारा microcurie में रहेगा. Then we have e raised to minus lambda, which is 2.949 into 10 raised to minus 8, and time is 3.1536 into 10 raised to 7. This comes out to be 2 into e raised to minus 0.93. This can be written as 2 upon e raised to 0.93. Now आप इसको log लेके आप इसको separately solve कर सकते हो. ये हमने part 2 में भी ये sum ऐसे किया था, x equal to e raised to 0.93 लेके, and then इसका log लेंगे तो you will have log x is equal to 0.93 log e, and this will become 0.93 upon 1 upon log e will be 2.303, and finally when you solve this you will get x का value somewhere around, this fraction का value somewhere around 2.536, which will give you the answer as 0.789 microcurie. Hope you all understood this. Next हम देख लेते हैं. A source contains 2 species of phosphorus. पहले वाले का हाफ टाइम है 14.3, दूसरे वाले का हाफ टाइम is 25.3 days. At t equal to 0 यानी इनिशियल एक्टिविटी दोनों का जब देखा तो वहां पे दे फाउंड आउट कि 90% ऑफ द डीके इज बिकॉज ऑफ दिस स्पीसीज, एंड they are asking how much time has to elapse for only 15% of the decays to be from phosphorus with mass 32. We have half-life for both of them. So half-life for phosphorus with mass 32 is given as 14.3 days. इसमें हम लोग lambda निकाल सकते हैं. So we got lambda 1 which is 0.693 upon half-life which is 14.3. This you will get as 0.04864 per day. Similarly, for phosphorus with mass 33, we got half-life time given as 25.3 days. So lambda in this case will be 0.693 divided by 25.3. This comes out to be 0.02739 per day. Now, they are saying that at t equal to 0, yani initial activity A0 for the first phosphorus which was having mass 32 is giving 90% of the activity और बचा वाला is giving the 10%. तो अगर मैं इन दोनों का रेशियो ले लेता हूँ, activity because of these two phosphorus, A01 is denoting activity of phosphorus with mass 32 and this one is for mass 33. Then the ratio is that this one is showing 90% activity और ये वाला is only showing activity 10%. This comes out to be 9. And then they want the time जब इनका पहले वाले का एक्टिविटी खाली 15% रह जाए. So we need to use this formula. Activity at time t is activity at t equal to 0 e raised to minus lambda t. So अब इसका रेशियो ले लेते. Activity at time t for first phosphorus with mass 32 और second वाले के लिए we will denote it this way. When we take the ratio, what we have is this is equal to A0 for first one e raised to minus lambda 1t and A02 for e raised to minus lambda 2t, and this is given as कि पहले वाले का हो गया एक्टिविटी 15% and दूसरे वाले का है 85%. So this comes out to be around 3/17. Now what we can do is we can take a ratio of this. So if this is equation number 1, ये 2 हो गया, we will take 1 divided by 2. So we will have A01 upon A02 and denominator में ये वाला पार्ट आ जाएगा. So ये मैं यहाँ पे इन्वर्स करके लिख दे रहा हूँ. So you got A02 e raised to minus lambda 2t upon A01 e raised to minus lambda 1t. This is equal to 9 और ये denominator में आ जाएगा 3/17. So A01 कैंसिल हो जाएगा, A02 कैंसिल हो जाएगा, e raised to minus lambda 1t ऊपर जाके plus lambda 1t हो जाएगा. So we will have e raised to lambda 1 minus lambda 2 into t और ये 17 ऊपर जाके 17 into 9 is 153/3 या इसको आप 51 लिख सकते हैं. We already know lambdas का value, lambda 1 and lambda 2. So we can take log over here. We will get lambda 1 minus lambda 2 into t log of e. This is equal to log of 51. ये log e आप उस बाजू ले लोगे तो 1/log e is 2.303. ये हम बार बार यूज कर रहे हैं, प्लीज रिमेंबर दिस. और ये हमने लास्ट वाले पार्ट में भी किया था कई बार. So from this we will have t is equal to 2.303 log of 51 और यहाँ पे lambda 1 और lambda 2 का वैल्यूज पुट कर देते हैं. So lambda 1 is 0.04864 minus 0.02739. This will give you the final time as 186.6 days. Hope you all understood this. Next वाला सम देख लेते हैं. Before year 1900, the activity per unit mass of atmospheric carbon due to presence of carbon with mass 14 averaged about 0.255 becquerel per gram. Becquerel over here means 1 disintegration per second. What fraction of carbon atoms were this isotope. An archaeological specimen containing 500 mg of carbon shows 174 decays in 1 hour. What is the age of the specimen? Assuming that its activity per unit mass of carbon when the specimen died was equal to average value of air, and half-life of this thing is given as 5730 years. So we got half-life as 5730 years. We can find decay constant 0.693 divided by 5730. इसको हम लोग सेकेंड्स में कन्वर्ट कर सकते हैं by multiplying by 3.1536 into 10 raised to 7. This will come somewhere around 3.83 into 10 raised to minus 12 per second. Now, activity which was there was 0.255 becquerel per gram, or you can say this is 0.255 disintegrations per second per gram. So we can find out number of atoms over here. Activity is given as n into lambda. So number of atoms n is equal to activity by lambda. So this is 0.255 divided by 3.83 into 10 raised to minus 12. This comes out somewhere around 6.65 into 10 raised to 10. So these are the number of atoms which are present. Now, number of atoms which are present in 1 gram of carbon. In 1 gram of carbon, number of atoms के लिए what we'll do is we will have 6.023 into 10 raised to 23 divided by the mass of carbon, which is 12. Okay, so this will give us 5.02 into 10 raised to 22. This is the amount of carbon atoms that are present per gram, and we need to find out what is the fraction of this atoms of mass 14, carbon atoms of mass 14. So what we'll do is we will simply take the ratio over here to get the fraction. So number of carbon atoms that we got divided by the number of isotope atoms that are present. So 5.02 into 10 raised to 22 divided by number that we got is 6.65 into 10 raised to 10. Now this comes out something around 0.75 into 10 raised to 12. So what this tells you is that for every 0.75 into 10 raised to 12 carbon atoms of C12, we got one atom of C14. Okay? So what I mean is there is one C14 atoms for every 0.75 into 10 raised to 12 C12 atoms. Okay? Now according to textbook, we can write this as, if we multiply this by 4, we will have 4 C14 atoms for every 3 into 10 raised to 12 C12 carbon atoms. Next, they have asked what is the age of the specimen, or time in simple words. So what we can do is we can find out present activity per gram. So present activity per gram, ये find कर लेते हैं हम लोग. Activity that they have given is 174 decays per hour. ये 174 decays को you can convert this into seconds. So 174 per hour is, you can divide by 60 for minutes into 60 for seconds. ये आपको आ जाएगा 0.04833 disintegrations per second. So we will use it over here. तो ये आ जाएगा 0.04833. This is the activity for the given weight. तो इसको हम इससे divide कर लेंगे 500 milligram से. So we will have activity per gram. So this comes out to be 0.0966 recurring है यहाँ पे disintegrations per second per gram. And initial activity they have already given over here, A0, which is 0.255 disintegrations per second per gram. So what we can do is we can use this formula, A of t is equal to A0 e raised to minus lambda t. You can write this formula in terms of time also. This is equal to 2.303 by lambda log of A0 by A over here, and this is the A that we got, activity that we got. So once we put this, we will get time somewhere around 8028 years. This is the age of the specimen that they have given over here. Hope you all understood this. Next वाला sum देख लेते हैं. How much mass of uranium with mass 235 is required to undergo fission every day to provide 3000 megawatt of thermal power? Average energy per fission is 202.79 mega electron volt. Now they want power to be equal to 3000 megawatt, or we can say 3000 into 10 raised to 6 watt can be written as joule per second. So this is what is there per second. अगर हमें energy का बात करना है, energy that is required per day, for this we need to multiply this 3 into 10 raised to 9. ये 10 raised to 3 हो जाएगा और ये 10 raised to 6 10 raised to 9 हो जाएगा. इसको हम लोग सेकेंड्स को डे में कन्वर्ट कर रहे हैं. सो विद इन अ डे वी गॉट 86400 सेकेंड्स. सो इससे हम मल्टीप्लाई करेंगे तो पूरे दिन भर का एनर्जी कैलकुलेट हो जाता है. विद दिस विल कम आउट टू बी 2.592 into 10 raised to 14 joules each day. Now energy per fission they have given us 202.79 mega electron volt. We will convert this into joule. Mega is 10 raised to 6 and 1 electron volt is 1.6 into 10 raised to minus 19 joule. This will come around 3.245 into 10 raised to minus 11 joule. This is the energy per fission. So what we'll do is we will divide to get the number of fissions per day. Number of fissions per day will be equal to 2.592 into 10 raised to 14 divided by 3.245 into 10 raised to minus 11. This comes out to be 7.988 into 10 raised to 24 fissions each day. These many fissions are necessary. We need to calculate mass over here, and for calculating mass we know that 235 gram of this uranium is having 6.023 into 10 raised to 23 atoms. So the mass needed over here will be 7.988 into 10 raised to 24. We will divide this by 6.023 into 10 raised to 23 into this weight. 235 gram can be written as 0.235. So this will give you the amount of mass required. It simply says for every 235 gram you got this many atoms. So for this much fissions you need this many atoms. तो उसके लिए कितना ग्राम्स लगेगा, तो ये फॉर्मूला से आ जाएगा हमें, and the answer comes out to be 3.116 kg approximately. Hope you all understood this. Let us check out the last sum. In a periodic table, the average atomic mass of magnesium is 24.312 AMU. The average value is based on relative abundance on Earth. The three isotopes and their masses are given over here, and the natural abundance of this magnesium with mass 24 is 78.99%. Calculate the abundance of other two isotopes. तो यहाँ पे percentage wise calculate कर लेते. Average we got 24.312. अब इसके अंदर ये जो 24 एटॉमिक मास वाला मैग्नीशियम है जिसका वेट दिया हुआ है 23.98504, इसका कंट्रीब्यूशन है 78.99%, और यू कैन से 78.99 डिवाइडेड बाय 100, प्लस ये सेकेंड वाले का 24.98584 AMU मास है. लेट अस से इसका कंट्रीब्यूशन है x. तो थर्ड वाला जो बच गया जिसका मास है 25.98259, इसका कंट्रीब्यूशन विल बी 100 minus 78 minus x. सो ये आ जाएगा 21.01 minus x परसेंटेज इसका कंट्रीब्यूशन हो जाएगा. सो दिस विल बी डिवाइडेड बाय 100. दीज आर परसेंटेजेस. ओके, अब इनको मल्टीप्लाई करके सॉल्व करना पड़ेगा सो दैट ये आंसर आ जाए. सो दिस विल बी इक्वल टू 18.9457831 प्लस ये सेकेंड वाला विल कीप एज इट इज 24.98584x divided by 100 plus 5.482325 माइनस में आ जाएगा 25.98259x divided by 100. Okay, और ये बाजू में अपने पास है 24.312. Now when we'll add and subtract all this, we'll be left with 0.99675 by 100 x. This is equal to 0.092725, which approximately comes out to be 9.3%. So this is the contribution of magnesium with mass 25, and for magnesium with mass 26 हम लोग 21.01 minus 9.3 कर लेते. It comes out to be 11.71%. Hope you all understood this. Thank you for your time. If you're finding this lecture series useful, then show us your appreciation by clicking on the like button, and don't forget to share it with your friends and classmates. Based on your feedbacks and suggestions, we'll be making videos under our 5 minutes lecture series for class 12. So please feel free to let us know the topics you want us to cover. See you all in the next class. This is Professor Sandeep from Physics HQ signing off.